See a job posting for $95,000 more than you make? That's not jealousy, it's the sound of the ground splitting beneath your feet. An AI engineer just got offered $195,000 for a job that looks suspiciously like yours. And in the dark, with just the glow of the monitor on your face, that $80,000 gap forces you to type the one question that's haunting the entire industry. Will AI replace software engineers? But that question, the one everyone is asking, is the wrong question. By the end of this video, you'll understand this great divide, and I'll give you the exact 3-step action plan to ensure you're on the right side of it. The truth is, the debate over whether AI will replace software engineers in 2026 is missing the point. It's coming to split the profession in two. We're witnessing the great career divide. On one side, the role of the pure code writer is shrinking. On the other, a new role is emerging, commanding a massive premium, the AI-Augmented Architect. The data is already showing this split in salaries. As of early this year, the average salary for a software engineer in the United States is around $130,000. Meanwhile, engineers with specialized AI and machine learning skills are already earning a 20 to 30% salary premium over those general roles. That's an extra $26,000 to $39,000 a year, not for being a better coder, but for being a different kind of engineer. And projections from industry analysts suggest that by 2026, this gap could widen to over 50%, creating a two-tiered pay scale within the same job title. This isn't about replacement, it's about leverage. It's the difference between writing code line by line and orchestrating systems that write code for you. The divide is widening every single month, and choosing which side you're on is the most important career decision you'll make this decade. Let me know with a simple yes or no in the comments. Have you felt this shift on your own team yet? That choice begins by getting brutally honest about one thing. What parts of your job are already a commodity? This split isn't some abstract future theory. It's happening right now in your IDE, on your team, and in your daily stand-ups. It's driven by the fact that AI is becoming provably better, faster, and cheaper at 3 specific high-volume tasks that once defined a junior developer's entire job. The shift is so significant that by 2025, 84% of all developers were already using or planning to use AI tools in their workflow. This isn't a trend, it's the new foundation. The first task being completely commoditized is writing boilerplate code and scaffolding new projects. Picture this. On one side of the screen, a traditional developer is starting a new microservice. They manually create the directory structure, initialize a package manager, install dependencies, and then type out the same server setup, routing, and database connection logic they've written 100 times before. It's meticulous, necessary, and takes about 45 minutes of focused, error-prone work. On the other side, a junior developer opens an AI-native IDE like Cursor. They write a single prompt, scaffold a new Python microservice using Fast API for a user profile system with endpoints for create, read, and update, connect to a PostgreSQL database, and generate unit tests for each endpoint. Less than 30 seconds later, the entire project structure appears, files populated, dependencies listed, and tests ready to run. This isn't just a 10% productivity boost, it's a 100x leap in leverage. The value is no longer in knowing the syntax for a server file, it's in knowing how to architect the system in a single clear command. The second task to fall is the generation of routine unit tests. For decades, writing thorough tests was a mark of a good engineer, but it was also the first thing to get cut under a tight deadline. Now, with tools like GitHub Copilot, which already has over 15 million users, an engineer can highlight a complex business logic function and tell the AI, write 5 jest tests for this function, covering the happy path, null inputs, and an edge case where the user is inactive. The AI doesn't just write the code, it reasons about the potential failure points. The engineer's job shifts from being a test writer to a test strategist, reviewing the AI's output and asking, what business-critical edge case did the machine miss? Finally, the third task being automated is basic first-level debugging. Think about the last time you saw a cryptic error message from a third-party library. The old workflow was a frantic scavenger hunt across Stack Overflow tabs, hoping to find a post from 6 years ago that was only vaguely related. The new workflow is to copy the error, paste it into a tool like Claude along with the relevant code snippet, and ask, explain this error and suggest 3 likely causes in my code. The AI acts as an infinitely patient senior developer, translating arcane messages into plain English and pointing you to the most probable lines causing the issue. When you put these three things together, scaffolding, testing, and basic debugging, you're not looking at a list of tasks. You're looking at the complete job description of a junior developer from 2021, and its market value is collapsing with every new model release. Let me know in the comments. Which of these three tasks has AI already taken over the most on your team? Scaffolding, testing, or debugging? I'm curious to see the trend. To help you see where you stand, I've created a simple one-page PDF called the AI Automation Audit. It helps you map your daily tasks against this list, giving you a quick way to see your own risk profile. You can grab it for free at the link in the description. That unnerving feeling in your chest right now? It's the sound of the foundation of your career cracking. And it's not because of what AI can do, it's because of what happens when a brilliant engineer decides their expertise is more valuable than their curiosity. Let me introduce you to Alex. He's a senior Java developer, the go-to expert on a critical legacy system for the last decade. His code is meticulous, robust, and he's proud of it. When his company started rolling out AI coding assistants, he dismissed them as toys for juniors, confident that his deep expertise was irreplaceable. We're now inside his performance review. It's not going well. His manager pulls up a dashboard. On the left is Alex's output for the quarter, a handful of complex bug fixes on the old system. On the right is the output of his peers working on the new platform modernization. They're shipping entire features, their velocity 3 times higher than his. Alex argues his code is better, more reliable, that he doesn't trust the AI's buggy suggestions. His manager sighs and points to the screen. Alex, she says, your peers are solving the problems we have now. The business can't wait for perfect code, it needs solved problems. You've made yourself the world's best maintenance crew for a museum. In that moment, Alex realizes his deep expertise hasn't made him an asset, it's made him an anchor. He's no longer the expert, he's the maintenance crew, and he knows with a sinking feeling that the next round of layoffs won't be targeting the juniors. Alex's story isn't fiction. It's the human face of a stark statistic. A recent Morgan Stanley survey of companies in AI-exposed sectors revealed an average productivity increase of 11.5%, but it came with a 4% net decline in headcount over the past year. That 4% isn't just a number, it's the engineers who believed their value was in the code they already knew, not in their ability to adapt. Alex failed to see that his value had shifted. The game was no longer about writing perfect code. It's now about leveraging imperfect tools to achieve business outcomes faster. The escape route from his fate lies in mastering the 3 human superpowers that AI, for all its power, simply can't replicate. The first is seeing the entire chessboard, not just the next move. This is complex system design. AI can write a function, a class, or even a small service, but it can't reason about the intricate trade-offs of a distributed system. It can't debate the long-term maintenance cost of choosing microservices over a monolith for a specific business context. It can't design a data model that anticipates future product needs. That ability to zoom out has become more valuable than ever. The second superpower is translating human problems into technical strategy. This isn't just business acumen, it's the ability to hear what a customer means, not just what they say. An AI doesn't know that a specific customer is threatening to leave, or that a new regulatory requirement is driving the roadmap. An engineer who can sit with a product manager, understand the true business problem, and then translate that fuzzy human context into a technical strategy is doing something an AI can't. They aren't just taking tickets, they are shaping the solution. And the third superpower is being the one they call when the playbook gets thrown out. This is creative problem solving for the bizarre, the novel, the problems an AI has never seen before. AI is brilliant at pattern matching. When faced with a truly unique challenge, a bizarre performance issue that only happens at scale, or a request to integrate 2 completely alien systems, it falls apart. The human ability to use intuition and to experiment is the engine of true innovation. Of those 3, which one feels like the biggest growth area for you personally? Drop a comment below. It's powerful to see what other engineers are focused on. Everyone talks about what skills to learn. The conversation misses the single career-killing mindset that makes you obsolete even if you know the tech. Alex had deep knowledge, but he lacked curiosity. He believed his value was in what he already knew, not in how fast he could learn. That's the mistake that will get you marginalized, not the AI itself. Alex's career became an anchor, but on the other side of the divide, some engineers are building rocket ships. Let's meet one. Her name is Maria. She isn't a research scientist with a PhD from a top university. Just a few years ago, she was a mid-level Python developer, a good coder, but not fundamentally different from thousands of others. She saw the shift happening and made a strategic choice to upskill. Now picture her in a planning meeting. She's at a whiteboard, but she isn't sketching out individual functions or database schemas. She's orchestrating a system. The conversation isn't about lines of code, it's about trade-offs. She's debating the latency implications of using a larger model versus the accuracy gains. She's discussing the projected monthly cost of their vector database at scale. Midway through the meeting, a colleague brings up a new technique they saw in a research paper. Instead of scheduling another meeting, Maria whips out Claude, feeds it the entire research paper, and says, "Give me the 3 implementation trade-offs, now." 60 seconds later, the meeting continues, but the entire technical direction has shifted based on a real-time insight. She's not coding, she is conducting an orchestra of intelligence. To master this new role, make sure you're subscribed because we're breaking down the specific system design patterns Maria uses in our next video. This is the critical identity shift. Maria's value isn't in her ability to write Python code anymore. AI can do that. Her value is in her ability to leverage AI as a cognitive tool to make high-level strategic decisions. The belief that you need years of specialized study to become an AI engineer is wrong. Becoming an AI-Augmented Architect is a strategic evolution of the engineering skills you already have. It's about consciously moving your focus from syntax to strategy. This new role is defined by someone who uses AI to design, validate, and orchestrate complex systems. They are the human guide for a team of powerful but unguided AI assistants. And this shift doesn't just change your daily work, it fundamentally changes your earning potential. When Maria was a standard software engineer, she was earning $120,000 a year, a strong salary. After deliberately repositioning herself and developing these architectural skills, her new role came with a salary of $185,000. That's a jump of over 50%. This is the concrete payoff. The 20 to 30% salary premium we talked about isn't the ceiling. For those who truly embrace this new role, it's the starting point. Maria didn't get here by accident. She ran a 3-step playbook to go from coder to architect. And that is the exact playbook I'm giving you right now. It moves you from simply using AI to strategically wielding it. First, you need to master your tools, not just use them. 84% of developers are using AI, but most are stuck asking for basic code snippets. That's the equivalent of using a supercomputer as a calculator. Mastery means going deeper. Instead of asking AI to just write code, start using it for high-leverage tasks. Before you refactor a complex piece of legacy code, ask your AI assistant to first write a comprehensive test for it. Once that test passes, then ask it to refactor the code for clarity or performance. Run the test again. If it still passes, you've used the AI as a disciplined engineering partner, not just a code generator. Use it to learn a new code base by asking it to trace a feature from the front end all the way to the database, identifying the key files and functions involved. This shifts the tool from a crutch to a cognitive multiplier. Second, level up on system design. Stop trying to learn another JavaScript framework. The single most valuable skill you can build in 2026 is high-level system design, because AI will write the boilerplate code for any framework you need. Your value is no longer in knowing framework-specific syntax, it's in your ability to decide which patterns and trade-offs are right for the business problem. Spend your learning time on architecture patterns, data flow diagrams, and understanding the second-order effects of your technical decisions. Shift your focus from "how do I build this component" to "what components should we be building and how should they connect to serve the business for the next 3 years?" Third, and most critically, develop your business acumen. This is the simplest step to start and the one most engineers ignore. This week, schedule a 30-minute coffee chat with your product manager. Don't ask about ticket priorities. Ask one question. What is the single most important business metric our team is trying to move this quarter and why? Listen to the answer. Understand it. The moment you stop seeing your job as closing tickets and start seeing it as moving a business metric, you are no longer a coder. You are a problem solver, you are becoming an architect. It's 11 p.m. again. The same engineer is at the same desk, the screen casting the same soft glow in the dark room. But the anxiety is gone. In the search bar, the cursor blinks, and instead of the fearful question, will AI replace software engineers? They confidently type a new query: system design patterns for RAG applications. In that moment, the shift is complete. They are no longer a victim of the future, they are an architect of it. The question was never about replacement, it was about which side of the divide you'll stand on. The future belongs to the architects using AI as the ultimate leverage tool. To see where you stand, grab the free AI automation audit from the description. For the full blueprint, my guide from SWE to AI engineer has the complete plan. My name is Pragati Kunwar and the link is below. Your first step tonight is to take one function from your code and have an AI explain it back to you. Start building that augmentation muscle right now. In our next video, we're deep diving into the system design patterns Maria uses to command that salary premium. You won't want to miss it.